So now that we understand what complex numbers are and we got pretty comfortable with working with them in all sorts of ways, now let's see how we would solve equations with complex numbers. So again, the words, it's solve using the even root properties, complete the square, and quadratic formula. So you're going to use the same type of processes that you used before for solving, except now your solution may end up having an imaginary number in it. It may be a complex number. Let's just let's do the work and it'll clear itself up here. So let's say we have this problem. Now, before, right, we would have gotten to this problem and we just said, okay, if you want me to solve for x, this is a perfect problem for solve using square roots, because you would have taken the square root of the left and the plus and minus square root of the right, and you would have gotten x minus 2, right, because this and this cancel, equals positive and negative square root of negative 20. Again, you could have added 2 to both sides here, and you would have gotten x equals 2 plus or minus the square root of negative 20. However, at this point, you would have said, oh, this is no real solution because this is not possible. However, again, now that we know complex numbers, we know that that is very possible, right? So all I have to do is simplify this at this point. So I know that this is going to be, remember my factors here, I'm going to do negative 1, 4, and 5, and then I'll pull out square root of 4 is 2, square root of negative 1 is I, so 2I radical 5. And so these are my solutions to this problem. Now, we keep going. We go to number 2. And again, we're in the same situation here. We've got this square root. We're going to do, all right, let's solve using square roots. So square root plus minus square root. And again, I'm going to get 3x minus 1 on the left. And on the right, you're going to get, again, really good at this, but the square root of negative 48. Now, we can leave it in there for now if you want. Let's just leave it. And let's move everything else over. Sometimes I like to simplify that last. Sometimes I could do it first. So first thing I'm going to do is add 1 to both sides. So I've got 3x equals 1 plus or minus the square root of negative 48. And then I'm going to divide everything by 3. And I'm going to get that x equals 1 plus or minus the square root of negative 48 over 3. Now again, I've got to simplify the square root of negative 48 part. So again, the square root of negative 48 is going to be, this is going to be negative 1, 16, and 3. So it's going to be 4I radical 3. So it's going to be 1 plus or minus 4I radical 3 all over 3. And that's fully simplified and it's solved. Now, when I get to number 3, this would be like a factoring question, right? So again, I would say to myself, okay, it's a trinomial. What numbers multiply to 5 and add up to 1? And I can't find it. So at this point, I'd have to say, okay, am I going to complete the square or am I going to use the quadratic formula? So I'm still solving like normal. I don't know at the get-go that these are imaginary solutions here or complex solutions. I just know I have to factor it. So let's say you were to do completing the square, which that would not be my first choice. I would probably do quadratic formula, right? But I'll do both. So completing the square, I would avoid it because the middle term is odd. The b is odd, and I don't like using it because it gives me fractions. But again, you'd have, let me move this over. So solve using completing the square, I would have x squared plus x equals negative 5, because I'd have to start by moving that 5 over, right? Then I would take half of 1, which is a half, and square it. And so a half squared would have to be added to both sides. This would be x plus a half squared. And this side would be negative 5 plus 1/4. So if I want to make 5 over 4, right, this is going to have to become negative 20. So now this side here, again, is x plus a half squared equals negative 19 over 4. Now I'm going to take the square root of this side and the plus minus square root of this side. So x plus a half equals positive and negative square root of negative 19. And I can even do the square root of 4s too, right? And then I'm going to subtract a half from both sides. So I get x equals minus a half plus or minus. Now, the square root of negative 19 is really I square root of 19 all over 2. So this is an acceptable way to write it. Or you could combine your numerators. So it'd be negative 1 plus or minus I radical 19 all over 2. And that's also acceptable. So again, where did the complex part come in? In the final answer at the end. So it wasn't immediately obvious that that's what you were doing. So again here, this could be any traditional factoring problem. My solutions could be integers, what numbers multiply to 10 and add up to 3. And so I think 5 and 2, right? However, notice that my product is positive. So it's either got to be plus 5 plus 2 or minus 5 minus 2, and none of those add up to 3. And so even though it looked like it was factorable, it wasn't. So again here, I could choose quadratic formula or completing the square. Since I did completing the square in the other one, let me do quadratic formula for this one, okay? So again here, my A is 1, my B is 3, and my C is 10. So x equals the opposite of B plus or minus B squared minus 4 times A times C all over 2 times A. So x is negative 3 plus or minus, and I get 9 minus 40 all over 2. So negative 3 plus or minus negative 31 over 2. And that's the answer. And so again, easy to do. I just factor like normal, either by factoring, by using the square root, by completing the square, or by using the quadratic formula. You pick your method. Again, it works. And so again here, solving the equation, again, if they give me these, I'm going to pick which way I'm going to solve. So again, notice that this one has no bx. Remember that standard form is 8x, ax squared plus bx plus c equals 0. And so here I don't have the b here. And so this is a perfect problem for square root. So I'm going to move it over. So x squared equals negative 25. I'm going to take the square root of this side, positive and negative square root of that side, and I'm going to get x equals plus or minus square root of negative 25, which means plus or minus 5i. And that's my solution. So I keep going here, I go to number 6. And again, I'm trying to see, well, can I factor it? Does anything multiply to 9 and add up to 2? It does not, so it's not something I can do. So again, I come over to here and I figure out how am I going to solve it. For me, I'm going to solve this one using completing the square because A is 1 and B is even. So I get x squared plus 2x equals negative 9. Half of B, half of 2 is 1, so I have to square it. So 1 squared is 1. So I get x plus 1 squared equals negative 8. Again, square root of the left plus minus square root of the right. X plus 1 equals plus minus square root of negative 8. And I'll subtract 1 from both sides, and I'll get this. Now, my last thing to do is simplify the square root of negative 8. I know that negative 8 is negative 1 times 4 times 2. And so it's going to be negative 1 plus or minus square root of 4 is 2, square root of negative 1 is I, and radical 2. And there's your answer. Again, keep going here. And when I look at this one, I immediately think this is a perfect one to solve using square roots. I'm going to move the number over. 25x squared equals negative 9. I'm going to divide both sides by 25. I like to isolate the x before I take the square root. So negative 9 over 25. And again, I'm going to do square root plus minus the square root. I'm going to get x equals plus or minus, and I'm going to do square root of negative 9 over the square root of 25. I can assign the negative to the numerator or the denominator. I'd rather just do it to the numerator. So again here, the numerator square root of negative 9 is 3i, and the square root of 25 is 5. So I've got plus minus 3i over 5. The plus minus doesn't really have to be next to the numerator. It can just be the whole thing. Basically, it's positive 3i over 5 and negative 3i over 5. And then this last one, again, I see this is another perfect candidate for completing the square. I could divide both sides by 3, and then I get the number that's being squared all by itself, right? And I get negative 16 over 3. Then I come in here and I do the square root plus minus square root, and I get x minus 1 equals positive and negative square root of negative 16 over the square root of 3. And then I'm going to add 1 to both sides. So I get x equals 1 plus or minus the square root of negative 16 over 3, like that. And so here I know that the square root, oh, this is square root of 3, sorry. It's going to be plus minus, now the square root of negative 16 is 4i over the square root of 3. Now the problem here is that I cannot have a radical in the denominator. So I do have to kind of multiply top and bottom by the square root of 3. So this is 1 plus or minus 4i radical 3 all over 3. And so that's your final answer. Now, for some of you, this might be a little bit confusing, so maybe, I'm just going to kind of leave the final answer there, but maybe when you get to here, some of you may prefer to simplify this side before you bring this one over. And that's something that I sometimes do. So like I might keep the x minus 1 over here, and I might work on simplifying this. I know this is 4i in the top, right? And this is radical 3 at the bottom. Again, I may do this part first, right? And then once I get, again, this is x minus 1, I have plus minus 4i radical 3 over 3. And then I might just want to bring the 1 over, you know, 1 plus or minus 4i radical 3 over 3. Again, I get the same answer, but the beauty of it is sometimes it's this side here can get so complicated. Sometimes it's better to just wait before you start bringing stuff over. At least that's, you know, a technique.